Hey guys, and welcome back to this Turdford video where we're doing the second part of doing a graph. So what we did in the last video was we basically laid out the graph basics. We got our scale laid out. We drew our axes on the graph, talked about how to make a scale. This was the other graph we were looking at, the 10 division paper. And it would actually be really nice for like this graph on this axis because it actually turns out to be every 10th line would be like 1, 2, 3, 4, 5, 6. So that would give us 0.1 for each line. So that would be nice. You always need to know how much every individual line is worth. So like in this graph, the way we laid it off, each line to the right is worth 0.1. Each line on the way up is 0.2. So we know what every increment of this lab is. So now what we need to do is this. Now we actually need to go through and look at our data. So at point 3, we've got 1 for a flow rate. So let's go back and graph that point on here. So at point 3, so I'm going to do some, can I actually get my view changed a little bit here? Zoom, page width. And I do that because I want you to be able to see what's going on. So we know that there's point 1, point 2. That means at point 3, it's told me that our flow rate is 1. So that means I need to put, and this is where some of y'all will put like this huge dot there, something. Guys, you need to try and keep it to where it is something is like, I usually just put a little tick mark like that. Nothing like too huge there. And then so for the next one at point 6, 2.014. I think that's close enough. 2.0, we can call it, right? So when we go back to it at point 6, so point 4, point 5, point 6 would be right here. So at point 6, that's 2.0. So same thing. I put my tick mark where my data goes. And based on how we've laid this out, we need to kind of round. So at point 0.9, that's pretty much 2.9. So where would that be on my graph? So as we go through again, so 0.9 would be right here. So there's 0.9. So at 0.9, we would be at 2.9. Well, wait a minute. I know going up, these are 0.2. So 2, 4, 6, 8, 3. So that means 2.9 would be like right dead in the middle. So I'm going to have to kind of guesstimate that one in the middle a little bit. No problem. Got it. All right. So next one, 1.2 at 3.8. And this is exactly what you'd need to do. 1.2 at 3.8. And so let's see, 1.1, so there's 1.2. And we've already said that that would be, and sometimes you got to use a ruler to help you out. So I'm going to be like tracking this line all the way up to where I get to, put me a little mark there to keep up with myself, to where I get to 3.8. And so there's 4, so 3.8 would be like the first line back. We are crushing this thing now. And if you're using the other graph, it'd be the same thing. So at 1.5, we're 4.7. I love where this is going. So where is 1 point? So at 1.5, now I've got a problem. There's 1.3, 1.4. There's 1.5. So I kind of need to, I'm going to give myself a little reference mark there so I don't lose that. So at 1.5, let's look at that data again. I have a short-term memory. 4.7. So I'm going to, where are we? So here is my line right here. And I need to go up to 4.7. Well, there's 4. So 4, 4.2, 4.4, 4.6, 4.8. So 4.7 would be dead in between that. And advantage of digital ink, I can get rid of all this garbage I put on here. Oh, I kind of made that line a little bit big. So there, shave it down. And now for the last data point, and guys, we can finish. this up. 1.8 is 5.6. Well, here's the thing. I already know this line's 1.5. So 6, 7, 8. And at 1.8, it was 5.6. So that would be that spot right there. All right, well, now that we've got all our dots on the paper, let's do something. So I'm going to view my whole page again. Zoom my entire page. And ooh, I've got a lot of trash on the bottom, but your teacher should understand why you've got a bunch of tick marks on the bottom of your paper. You've been counting a whole lot. So now the goal is to do what's called a best fit line. So take a ruler out, and whatever you do, this is not connect the dots. So your goal is this: take your ruler, preferably a transparent one, and what you're going to try and do is take your ruler and lay it on your paper in such a way that you can, and by the way, you do not have to go through the origin of your graph. A matter of fact, sometimes it's important that it's not through the origin. Like mine's not going to be directly in the origin, it's going to be close. But the goal is to try and put your ruler through the center of all those marks. Now, what's neat, my data's kind of fake, so it's touching them really well. But here's the thing: when you go to do this, guy, a best fit line, you may have dots that are very imperfect. When you put your line on there, that's going to be like the goal of your line. Your line is going to go through the middle of all of them. And this is your way of removing error out of your lab. You're kind of splitting the difference of all those points on there. And so that's exactly what I'm going to do right now. And I'm going to make sure that my line really stands out nicely on here. So I'm going to start. And by the way, watch how I do this. I'm going to draw my line. If I'm going to draw the line as long as the ruler is. So don't just kind of like stop here, there. A lot of times I have my students draw the line across the entire page. Oh no, I didn't hit that line. It's okay, guys. Really, it is. So now we've got our, and I'll throw that down here again. It's the word of the day. The word of the day is best fit line. So now how do you get the slope of this graph? So I'm going to go back, view, zoom, and I'm going to go page width because I need to be able to see. I'm looking for spots on this graph, and I'll show you what I mean. This is why this paper is not as good. In other words, it's easier to make a graph on this paper because essentially what I'm looking for is this. I'm looking for somewhere along this line where like you have this perfect like going right through the middle, like where the line just goes perfectly right through. And so I don't have this paper, I don't even have half the number of lines that I had on that other graph. So I'm going to have to find two spots where it's at least pretty close. So in other words, I'm looking to see like where it squarely goes through the middle of one. And on this paper, it's probably not going to be perfect. So I'm going to find two of my best spots. So I'm going to go with this spot. So notice what I'm going to do. I'm going to take that spot. I'm going to put a little X right there. Boom, boom. I'm going to mark it. So I'm going to say that spot, do not pick your data point. Somebody will come in. They'll be, oh, there's my data point. Do not use data points. And I lost my graph. Actually, did I delete my graph? I hope not. Be terrible. All right. So there's one spot. Now here's the goal. I need two of these. If possible, I like to get them kind of far apart, but again, I cannot be too picky on this graph. So let's come down here and whoo, this might be as close as I get. This spot right here. So I've got two of these spots, and now I'm gonna write down the coordinate of this. So here we go. These are my coordinates. So x1, comma y1, and so I'm gonna look and be like, all right. So what is my x position at this spot. Okay, well, I can do that. So let's see. Every line across the bottom was point 0.1. So that means if I started counting, that'd be 0.1, 2, 3, 4, 5, 6, 7. So this is 0.7 to the left, comma, and then I could count up. And counting up, ooh, they were 0.2. So this is 2.2. And now I would go up and I would find the same thing on the other line. And so I may have to get a little bearing here on myself on the other line. Let's see, that last data point was 1.8. Okay, I'm good now. So this I would call x2 comma y2. So 1.8 and 1.9. Oh, perfect. That's 2.0. So 2.0 comma, how far up am I? 5.2. And now I've got my data. Oh, that's nice. And so now that I've got my data, the next thing I can actually do is calculate my slope. I'm going to change my pen size just a little here to make sure this fit. So to find slope, slope is equal to, most of us call it rise over run, correct? Or we could call it rise is our change in y over my change in x. Or I can call it y2 minus y1 over. So we've got all these formulas and they all mean the exact same thing. So all I want to do is fill in this data. So y2 was 5.2. So 5.2 minus y1 was 2.2 over x2 was 2.0 minus 0.7, and that would be equal. I'm going to write my units down for a second here off the side. So all this stuff is meter cubed per second over meters per second. So I kind of want to keep this somewhere because I need to keep up with those units at the end for my slope. And now I can put this in here, and when I divide that out, I've got 3 on the top, 3 meters cubes per second over 1.3 meters per second across the bottom. And now take a calculator, 3 divided by 1.3, and I've got an answer of 2.3. And there's my slope. 2.3 meters cubed, wait a minute. Meter cubed divided by meter, that's meter square. Second over second, that cancels. So all I've got is a meter square for a unit. Now, what should be interesting about this is trying to figure out what this graph means. So you've made a graph. You've made a graph of flow rate in meters cubed per second versus velocity in meters per second. And now what's fascinating, you got a slope of 2.3. So your slope is equal to 2.3 meters square. Now, as I do that, now I should start going, wait a minute. I know that y is equal to mx plus b. Now, this is getting pretty interesting. So my y was the letter q. My m is this 2.3 meters square. My x was the letter v. What was my intercept? Let's go look real quick. What was that? This is where a computer's great. We'll just have to look at by hand. I'm going to go ahead and tell you, I think my y-intercept, I think we can boldly just call it my y-intercept, so letter B. Let's call that 0. We're pretty much on it. So we can call that 0. Wait a minute. Meter square. What is a meter square the unit for? Hey, Q is equal to area times volume, and I have derived the equation for flow rate. So, and it's kind of funny, so many people leave off this last part, but that's the cool thing. It's like, what did your graph actually tell you? So anyways, I'll do one more video in this series, guys, and in that one we'll talk about how to actually calculate using, say, for example, Google. But anyway, take it easy, guys. We'll catch you later. Bye.